Okay, today what we're talking about is Chapter 2-4 Concept Bite. This is the section that is before your 2-4. I'm going backwards because this is evaluation and it's piecewise functions, but it is something that is important for you to be able to do. So, for those of you who need to know how to do it, or would like to know how to do it, it is on page, making sure I got it right, on page 90. It's actually after the section. So, this is page 90 in your textbook. What we're doing today are piecewise functions. Piecewise functions are one function that has a different function rule for different parts of the domain. So basically what it is it's two functions put together, but they have a domain restriction. In other words, an example of a piecewise function is going to be f of x is equal to negative 2x plus 4, only used when x is greater than or equal to 4, and then x plus 6x plus 1 only used when x is less than 4. So you have two functions in one function. Okay? A piecewise function is two functions put in one function. They're only used when the domain is specified for that specific value. Now, what we're doing today is an evaluation of a piecewise function. So I want to evaluate f at negative 2. So the question you ask yourself is, where does 2 fall in the domain? Well, whenever I say domain, I'm talking about these restrictions right up here, the highlighted ones. X is greater than or equal to 4, or x is less than 4. So, is it below 4 or is it above 4? Well, 2 is actually below 4. Since it's below 4, I'm going to be using the 6x plus 1 function. So that means I'm going to be using the 6x plus 1 part of the function, and every place I see an x, I'm going to plug in the value 2. So that's going to be 6 times 2 plus 1. So 6 times 2 is 12, plus 1 is 13. So that means I would have the ordered pair, f at 2 is 13, which means it's an ordered pair 2, 13. I could actually plot that point. This time I want to do f at 6. What's the question? Where does 6 fall? Where does 6 fall in domain? So if we look at this, six would actually be greater than 4. And since 6 is greater than 4, I'm going to use this part of the function, which is going to be negative 2x plus 4. Why? Because it's in the part of the domain where it's greater than 4. So negative 2x plus 4 is what I'm using. And every place I see an x, I plug in the value 6. So negative 2 times 6 plus 4. What's negative 2 times 6? Negative 12. Plus 4 gives me negative 8. So now I have f at 6 is equal to negative 8, and that translates as the point 6, negative 8. Last one, f at 4. What's the question we asked? Where does 4 fall in the domain? Well, 4 is going to be equal to 4. So which one of these, in the original problem, allows it to be 4? Well, if we're looking at this, this one says x is greater than or equal to 4, and the bottom one says x is less than 4. So the one I have to use is going to be the top one, which is negative 2x plus 4. So I'm using negative 2x plus 4, and every place I see an x, what am I doing? Plugging in the value 4. So negative 2 times 4 plus 4. Negative 2 times 4 is negative 8. Plus 4 gives me negative 4. What does this mean? that f at 4 is equal to negative 4, so I can graph the ordered pair for negative 4 if I wanted to. The next one, same type, different piecewise function. This one gives you the function x squared plus x minus 2 when x is greater than 0, and then 2x minus 10 when x is less than or equal to 0. So I want to know negative 4. Well, if I'm just giving you negative 4, that's the same thing as saying f at negative 4. Why is f at negative 4? Because it's referring to the f function. So what's the question I ask myself? Where does negative 4 fall in the domain? So where does negative 4 fall? And where am I comparing it to? I'm comparing it to the value 0. Why 0? Because that's what it is in each one of these. So is it greater than or less than 0? Well, negative 4 is going to be less than 0. Since it's less than 0, I'm going to choose this part of the function, which is going to be 2x minus 10. Every place I see an x, I'm going to plug in negative 4. 2 times negative 4 minus 10. 2 times negative 4 is negative 8. Minus 10 gives me negative 18. So I have the value f at negative 4 is equal to negative 18 to give me the ordered pair, negative 4, negative 18. Part B is 0. So the question, where does 0 fall in domain? What am I comparing it to? Well, I'm comparing it to the value, looking back up here, 0. So what is 0 compared to 0? 0 is equal to 0. So I need to scroll back up here, and I need to say, okay, well, which part of this function am I going to use whenever it's equal to 0? So if it's equal to 0, I'm going to use the same function I used before, 2x minus 10. So I'm doing f at 0 at 2x minus 10. Every place I see an x, I plug in a 0. 2 times 0 minus 10. 2 times 0 is 0. Minus 10 gives me negative 10. So f at 0 is equal to negative 10 to give me the point 0, negative 10. What's special about that point? Alarm should be sounding. You should say, well, that's nice. That's the y-intercept. Next one is c at 3. That means I'm doing f at 3. So where is f? Where does f fall? 3 falls, sorry, in the domain. I'm comparing it to 0. 3 is greater than 0. So 3 is greater than 0. Which function am I using? Well, if it's greater than, I want this one right up here. So I'm going to be using this x squared plus x minus 2. And every place I see an x, I'm going to plug in 3. So that's 3 squared plus 3 minus 2. 3 squared is 9 plus 3 is going to give me a 12 minus 2 gives me 10. So f at 3 is equal to 10. To give me the ordered pair, 3, 10. Okay. Same exact concept, but this time, I'm going to put these up a little bit more. Okay, g at negative 3. If I'm doing g at negative 3, I need to compare this. Well, I have a lot more restrictions this time. Where is negative 3? Does it fall in this restriction? Does it fall in this restriction? Does it fall in this restriction? Well, negative 3 is going to be between, is negative 3 between negative 5 and negative 3? It cannot be this one because it's not equal to it. So it can't be that one. Does it fall between negative 3 and 1 on this one? Yes, because it can be equal to it. Does it fall between 1 and 3? Well, no, it's not in that region, so the one I'm actually using is going to be 3. Well, how can it be the function 3? Well, that's a horizontal line. That means it doesn't matter what value I plug in, the outcome will always be 3. So I have the ordered pair, negative 3, 3. There's nothing to plug in there. The next one is negative 6. Well, same concept again. Where's negative 6? Is negative 6 between negative 5 and negative 3? Well, no, because negative 6 would be down here, so I can't use that one. Is it between negative 3 and 1? No, it's not in between there. Is it between 1 and 3? No, it's not in there. So what does that mean? Can I use this value? Well, no. That means there's no solution there because I have nothing to plug into. It means it's not defined there because it doesn't fit into any of my restrictions. Since it's not in any one of those, it automatically means there's no solution. Okay? So now let's go to the next one. G at 2. Well, if I'm doing G at 2, is 2 in between negative 5 and 3? Keeping in mind, here's 0, 1, 2, 1, negative 1, negative 2, negative 3. It's not going to be in between here. Is negative 1 in between, is 2 in between negative 3 and 1? Well, no, because 2 is going to be out here, right? So this one doesn't work. Is it between 1 and 3? Yes, it is between 1 and 3, so therefore I need to go ahead and choose the function 3x minus 6. In every place I see an x, I plug in a 2. So 3 times 2 minus 6. So that's 6 minus 6, which is 0. So g at 2 is 0. More importantly, my ordered pair is going to be the point 2, 0. Guess what point that is? The x-intercept. Okay, we've done a lot of evaluation. Now, how do we graph something? How do we graph something? Now, if I want to graph this thing, I have 3 different functions that I can graph. The first function is going to be x plus 1. And I'm going to set that equal to y because it's a line. If I try to graph this, what's my slope? Well, it's already solved for y, so my slope is going to be 1 over 1. So that's going to be graphically up 1 to the right 1. What's my y-intercept? So that's my b value, which is going to be the point 0, 1. Well, I got a lot of information out of that. So what I'm going to do is I'm going to actually go over to the next page here. I group this together. I copy it. I'm going to go here, and I'm going to paste that in. This is my first equation. So I need to graph this point starting at 0, 1, up 1 to the right 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 1. So there's my equation. Okay? Now, by definition of a piecewise function, this says that I have restrictions on it. If I go back here, this says I only want this to be graphed from negative 5 to negative 3. So what we're going to do is I'm actually going to draw little cutters here, just like you did back in grade school. We're going to start this at negative 5. Why? Because it says to start it at negative 5. And I'm going to end it at negative 3. So at negative 5, 2, 4, 5, I'm going to draw a dotted line. And at negative 3, I'm going to draw a dotted line. So what this means is I only want this part of the graph in between those x values. So I'm literally going to shrink this down. So if I shrink this thing down, I'm going to come all the way here. I'm going to bring this all the way up, and there's my graph, meaning I do not need those values. I'm going to get rid of the highlight, and then I'm going to come back over here and I'm going to say, is it supposed to be opened or closed at -3? Is it allowed to be -3? It is going to be open at -3, and then at -5, it's going to be closed. Why is it closed at -5? Because it's the less than or equal to symbol. Why is it opened at -3? Because it's the strictly less than symbol. So I'm going to come back over here to my graph, and I'm going to have an open dot here, and I'm going to have a closed dot here. Now I'm going to delete my little cutters, and I've graphed the first part of that equation. I'm going to make the circle look better here. Okay? Now, I need to graph the second part of my equation. The second part of my equation is going to be y is equal to 3. I understand that there's no y there, but remember, this g of x is the same thing as y. So I can say y is equal to this, y is equal to this, and y is equal to this. So if y is equal to 3, what type of a line is that? This is a horizontal line. So I come back over here, and I am simply going to draw a horizontal line at 3. So there's my horizontal line at 3, and then what am I going to do? I'm going to put my cutters in. So I'm going to come back here, I'm going to say, well, what am I cutting from? I'm going to go from -3 to 1. So at -3 and at 1, what's happening? Is it open or closed at -3? It's the less than symbol or equal to symbol, so this is going to be closed. And at 1, it's going to be less than symbol, so that's going to be open. So I need to draw my cutters between -3. So here's my cutter at -3, and then at 1. And I'm going to shrink this line down. So I take my line and I push it all the way in. I take this line and I push it all the way in. And oops, I didn't want to push it. Okay, I'm going to the mouse. So now I come back over here, and it's going to be closed at -3, and it's going to be opened at 1. So I'm going to be closed at -3, and it's going to be open at 1. So I'm going to delete my cutters. So there's the next part. Now my third part of my equation is going to be y is equal to 3x minus 2. Well, what's my slope? 3 over 1, so up 3 units to the right 1. And my y-intercept is going to be b, which is going to be 0, -2. I'm going to come over here and I'm going to graph that. I'm going to start at 0, -2. I'm going to go up 3 units, 1, 2, 3, and to the right 1. 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 So there are my points. Now I'm going to connect the dots. Okay. So I come back over here, and now I need to get my cutters. So I'm going to come down here, and I'm going to say, well, I need this between 1 and 3. So I'm going to come over here, and I'm going to use my cutters. And I need it at 1, and I need it at 3. So if I'm doing 1 and 3, if I'm doing it at 1 and 3, okay, so my cutters are up there. So I need to go back over here and I need to say, okay, well, where are my restrictions? Well, my restrictions are going to be from 1 to 3, and at 1, it's going to be the less than or equal to symbol, so it's closed. And at 3, it's going to be the less than or symbol, so it's also closed there. So I come back to my graph, and at 1, it's going to be closed, and at 3, it's going to be closed. See where they intersect? Cutters? And then I need to shorten these up. So I'm going to come all the way down here and land on that dot. I'm going to come all the way up here and land on my cutter area. And then I'm erasing these other points because I don't need them. And then I delete my cutters. So that cutter is gone. That cutter is gone. And there is my lovely open dot. There is my graph of my piecewise function. So if I graph these three together, the picture of that is going to be this right here. And how do we check that? You're going to check that by going from the lowest point, which is -5, to the highest point, which is 3. If you look at that, you can see, there it is, that that's where they start and stop. So, tonight for homework, you guys owe me the chapter 2-4 piecewise function worksheet. You guys will need graph paper. Actually, you will not need graph paper because there's a graph on the back of it and you can graph it there. Due tomorrow.